Hey guys, Mr. Sullivan here. Hey, we're continuing our review for the AP Calc exam. And what we're going to do right now is kind of go back and go through each of the 7 units that are going to be tested. And we're going to go back to Unit 1, which is on limits and continuity. And I've got 3 free response questions. This was your homework tonight. And I'm just going to kind of run through and show my solutions to those. So question 1. It's a no calc problem. It says show all your work, even though the question may not explicitly remind you to do so. Clearly label any functions, graphs, tables, or other objects that you use. Justifications require that you have mathematical reasons, and that you verify the needed conditions under which relevant theorems, properties, definitions, or tests are applied. The work will be scored on the correctness and completeness of your methods as well as your answers. Answers without supporting work will usually not receive credit. Unless otherwise specified, answers, numeric or algebraic, need not be simplified. Your answer is given to a decimal approximation. It should be correct to 3 decimal places after the decimal point. And again, like we talked about, we're always going with just given 4 decimal places, just truncated after the 4th, and we're good to go. Unless otherwise specified, the domain of a function f is assumed to be the set of all real numbers x for which f of x is a real number. All right, so here's our problem. We're given the graph of f. So obviously right here. And we're also given some information about function g in table form. So it says the graph of function f is shown in the xy plane above. F has a discontinuity due to a vertical asymptote at x equals 6. So if we kind of look at that, okay, at x equals 6, yep, it looks like we've got a vertical asymptote for f. And then it says let g be a function that is continuous and increasing for all x. Values of g at x at selected values of x are shown in the table above. Okay, so we are given f graphically, and we're given g numerically in a table. All right, so let's see what we're asked to do. So part A says using the graph of f in the table of g, estimate the limit as x approaches 0 of f at x minus g at x. Okay, well, limit properties tell us that the limit of a difference is equal to the difference of the limits if the limits exist. So let's take a look at that. I'm just going to rewrite what we're given here. And again, the limit of a difference is equal to the difference of the limits, which means it's going to look like this. The limit of f of x as x approaches 0 minus the limit of g at x as x approaches 0. Okay, so now I'm looking for this first part, the limit of f of x as x approaches 0. So I'm going to the graph of f as x approaches 0. And again, I need to approach 0 from both the left and the right and see if f is approaching the same value. It looks like it is. So as I'm approaching 0 from the left, looks like it's approaching a value of 2. And as I'm approaching 0 from the right, also approaching a value of 2. So the limit of f of x as x approaches 0 is 2. Okay, and now I'm going to evaluate the limit of g at x as x approaches 0. So I'm going to go to the table. And again, I'm interested in the x values. And I would see a value, x value of 0 would be right there in the table. So my table is set up so that I'm approaching 0 from the left and 0 from the right. So what I'm interested in is I'm looking at these g at x, the y values, and it looks like they, as I approach 0 for the left in the table, are getting closer and closer to, looks like 2. And then I do the same thing. I'm looking at the y values as I'm approaching 0 from the right, and it also looks like I'm approaching a value of 2. So I can estimate, or I can approximate from my table, the limit of g at x as x approaches 0 is 2. So 2 minus 2 is equal to 0. Therefore, the limit as x approaches 0 of f of x minus g at x is equal to 0. Okay? Okay, part B, evaluating the limit given a graph. So it says for each of the values a equals 1, 2, 4, and 6, find the limit of f of x as x approaches a, or explain why the limit of f of x as x approaches a does not exist. Use correct limit notation in your answers. Okay, well, let's take the first one. So I'm going to just rewrite that using a equals 1. I'm going to have the limit of f of x as x approaches 1. Well, in order for that to be true, I'm going to have to show that the limit of f of x as x approaches 1 from the left is equal to, I'm going to put question marks over my equal sign because I don't know yet, the limit of f of x as x approaches 1 from the right. And that's that indicator. So now as I look at my graph, and I'm interested in an x value of 1, which is right here, I can see that as I approach 1 from the left, it looks like my y value is 1. That would be that value. But then as I approach 1 from the right, looks like the y value, the value of the function, is approaching 0. So I can show here that obviously 1 does not equal 0. So therefore, the limit of f of x as x approaches 1 does not equal, that does not exist. So I'm just going to say the limit f of x as x approaches 1 does not exist because limit of f of x as x approaches 1 from the left does not equal the limit of f of x as x approaches 1 from the right. Okay? As the limit of the function as x approaches 2. Might be an easier way just to go straight to the graph on that. So if I look at this, now I'm interested in as x is approaching 2, the function. And so again, I need to look at as I approach 2 from the left and as I approach 2 from the right, I get on the function, and it looks like it's an approaching a value of 1 from the right, the value of 1 from the left. So the limit of f of x as x approaches 2 is equal to 1. Okay, so look at limit of f of x as x approaches 4. Same thing again. I'm going to look at my function. Now I'm interested in x value of 4. And again, I need to look at it as I approach from the left. Well, it looks like my function is approaching -1. And as I approach from the right, it looks like it's also approaching -1. So the limit of f of x as x approaches 4 is equal to -1. And last but not least, as I look at the limit of f of x as x approaches 6. Okay, well now I'm interested in x value of 6. So I need to look at, okay, well, as I approach 6 from the left, looks like my function is going to positive infinity. And as I approach 6 from the right, it looks like my function again is going to positive infinity. So there I could write the limit of f of x as x approaches 6 is equal to positive infinity. I could also write the limit of f of x as x approaches 6 does not exist. Okay. Okay. Part C is F continuous at x equals -3 using correct notation. Justify your answer. Okay. Well, if I'm asked to find if F is continuous at x equals 3, I need to show that my three conditions for continuity at a point have been met. My first condition is F at -3 exists. I'm going to my function and I look at x equals -3, which is right here. And I see that it does exist, and this is the value, it's 2. So F at -3 is equal to 2. My second condition, the limit of f of x as x approaches -3. Does that exist? And if so, what is the value? Well, now, again, I'm interested in x equals -3, so I'm on the function. As I approach from the left, looks like my function approaches a value of -1. And as I approach from the right, it also approaches that value of -1. So the limit of f of x as x approaches -3 is equal to -1. And now my third condition for continuity at a point, are these two, the value of the function and the limit, equal? Well, no. So I can say that f at -3 does not equal the limit of f of x as x approaches -3. Therefore what? F is not continuous at x equals -3. Okay? Okay, part D, write a difference quotient that best approximates the instantaneous rate of change of g at x equals 0. Okay, so I'm talking about function g. I'm asked to write a difference quotient that best approximates the instantaneous rate of change of g at 0. Well, that's really asking us to approximate g prime at 0. That's the instantaneous rate of g at x equals 0. So I'm going to go to my graph, and I'm going to take part of my graph here, just so I can kind of see it. Just going to copy that down below so I can refer to it. There it is. Okay. And if I want the best approximation at x equals 0, which is going to be at this point right here, my difference quotient is basically just going to be g at 0.001 minus g at -0.001 over 0.001 minus -0.001. Okay, can't quite leave it like this. I need to take care of the function notation. So g at 0.001 is 2.001 minus g at negative 0.001 is 1.999 over 0.001 minus -0.001. All right. All right, guys, I hope that's a help. That's that first FRQ on the problem set. All right, good luck.